So good evening, all of you.
Good evening.
Good evening, Swami.
Good evening, sir.
Yeah, good evening. So one minute, let me connect with whiteboard. Setting right. So still currently working part-time. Only few classes. So for complete recovery, it may take another 2 months time. Yeah, do you see my screen, sir?
Yes, sir.
Yeah. So this is the program for training program for the PySpark. Okay, so prerequisite for this, I just want you Python. So in Python, a few things are required. Just the prerequisite list I give you. If you don't know, just tell me. So for the notes purpose, I will open Google Docs here.
So PySpark, we have any software, so we are going to work on Google Doc.
In Google Colab, you can set up everything.
Okay.
So for the cluster setup, such kind of things, the Databricks are required. In the Databricks, we can do cluster setup with a single mission, with a single node. You want to execute for the practice purpose, you can use Google Colab.
Okay.
Yes, sir. Which is the best one to use it for practice?
For practice purpose, go with Google Colab. If you only practice all the PySpark code with the Databricks cluster, means the bill will be very high for you.
It's like when we are using a Google Colab, already we are getting a predetermined all the codes and
Yes.
all. So it's not like we are not doing any practice.
Yes. But for the setting up, you need to follow some instruction steps or there some. Okay. So once practical part started, I guide you about that.
So prerequisite part, yes.
So prerequisites for this PySpark is one is Python. The second one is basic SQL. So within this Python, I don't want complete Python. Very simple. Like once you know collections. What are the collection types here?
List.
And
List.
Tuples.
List, sets, tuple, dictionary.
Set.
And additionally, I want you grep or if statement and nested if statement. And creating functions. and for loop, while loop. If you know these things, you can understand all my PySpark coding.
Okay.
And one more thing as part of the SQL, like a create statement as part of the DDL.
So only DDL, sir, not about DML.
In the DML, what you need, select with where group by,
Where group by
and having class,
having clause
order by.
order by.
So these things are enough as part of the select, and additionally update, delete. Before that, insert. And additionally, you need something like unions.
Union.
Outer unions.
Joins.
Union and joins.
These are enough to work with my PySpark SQL. In the PySpark, there is concept called SQL. Okay.
Yes, sir.
So within this, like you have all types of joins, like
Inner join,
inner
Left
join,
join,
outer join,
Left.
left
join.
right join, and outer join.
right,
Right join.
Full outer.
And left
and full join.
join.
I hope all of you know this. If you don't know, like please attend parallelly those sessions. Okay. Let's come to the Spark part.
Sir, Python, when will be using it? Actually, it's only 2 days. I have been started with Python course.
Just your starting stage, huh? No problem. Just within few days, this part will be completed. Meanwhile, like in the first 4 or 5 sessions will be theory about the Spark. Okay.
Okay.
So meanwhile, you just go through the Python part in parallel, no problem. It's not a complicated thing.
Okay.
So what exactly the Spark first? You have to understand. So Spark is not a database or is not like a storage system. It's not anything. Spark is specially dedicated for data processing. So
Data
simply,
process.
Spark is an execution engine.
Execution engine. Yes.
Can we take it as an example, sir? Like when we have data collected completely, then the Spark is going to execute with that.
Yes.
Okay.
Spark is an execution engine with 2 features. Number 1,
In memory.
memory. In-memory computing.
In my computer.
Second,
MPP, massive parallel processing.
yes, MP. Massive parallel process.
It's massive parallel process.
Yes.
Okay.
Okay.
Yes.
Can we get an example for massive parallel processor?
Yes, step by step I will come with just concentrate here. So before getting into the technicals of this Spark, some basic background we need to understand. First about scaling, we'll talk about scaling. scaling types. So if you understand the scaling types, then why parallel process is not possible in regular systems, why it is possible in Spark, Hadoop kind of systems, you can understand. Basically, two types of scalings.
There are two types of scalings.
Vertical scaling. Second thing,
Mhm.
horizontal.
Horiz- Horizontal scaling.
Horizontal scaling. Nowadays, latest trend in the data processing is horizontal scaling. Okay.
So this is one of the most important things.
Yes. Generally, but vertical scaling is not outdated one. Vertical scaling is for small systems. I mean, for small data.
So vertical scaling is used for small data.
Large data.
Large. That means give a good word for this.
Yeah. And horizontal scaling is for big data.
That is for big data.
Okay.
First, we try to understand what is vertical scaling.
Yes.
I'm going to talk on vertical first. Then we understand what are the problems with this. Then we will find a solution with horizontal. Vertical scaling. As part of the vertical scaling, here one CPU. That means your laptop or any desktop machine, you take it, you will find one CPU. Within this CPU, three major components on the motherboard. What are those?
Okay.
You have RAM,
RAM.
Hard disk.
you have hard disk,
And this.
Motherboards.
motherboard is so for the motherboard, all these things will be connected. Major things within the CPU, the CPU components,
Processor, sir.
processor,
Third is processor.
and one
Yes.
more. Your
Graphic
disk.
card.
That is additional. GPU is a part of RAM only. RAM with processor. The graphic card includes of those things. Let's say hard disk for your easy understanding. Think that here I have 16 GB RAM and you have 10 gigahertz processing speed.
16 GB RAM and 10 gigabyte.
Let's say 1 terabyte.
1 terabyte.
1 terabyte means,
Big data storage.
1024 GB. This is the
1
thing that
TB. 1 TB.
1 TB. Think that in the beginning, you have less number of customers, less volume of data.
Okay.
Okay, and even less number of applications also. In this moment, if this CPU is a server for your application, the performance may be good. Understand?
Yes.
Yes.
Think that suddenly by next year, after 1 year, your data volume tripled and the number of customers so increased for 10 times. Okay, applications also not one or two applications also 100. If all 100 applications are running in this server, and also like lakhs of users are at a time logging into the application, and also data volume got increased drastically. Now same server is giving you slower performance. Understand?
Yes.
Again, after 2 years, think that data volume again 10 times doubled, number of customers 20 times increased. Like this, if all the load applied on this server might be hanged out. Got it?
Yes.
So now it's a time to scale the capacity. That means scale up. You are increasing the capacity means scale up. Decreasing the capacity means scale down. In what way that we can scale up in the vertical style is RAM not sufficient. That's why one more 16 GB RAM I am adding. Okay. Hard disk, I'm increasing. So processor, I cannot increase. I'm replacing
Yes.
20 gigahertz with some 20 gigahertz. And I want to increase the storage capacity means I'm
Two-
adding
2
one
GB
more hard disk.
terabyte.
1
Okay.
terabyte.
Now what is the total storage capacity here?
2 TB,
2
sir.
TB. What is the processor capacity?
20,
20 gigahertz. What is the RAM capacity?
32.
32 GB. Now capacity increased or not?
It does.
Now this might be good for the new data loads. Again, after some time, again data volume, again load highly created. Workload created, data volume also very heavily increased. Again, I need to scale up. One more RAM chip I need to add it.
Yes. Plus 16.
I cannot add one more processor. So that's why I'm replacing old processor with some other high capacity processor. Okay. Suppose in my motherboard, I can add two hard disks. I cannot add one more third hard disk. In my laptop, I can add 4 RAM chips. I cannot go beyond 4. That means here, based on this limitation, can I go unlimited data here in this style?
No.
I cannot go. So this is the problem. So first we try to understand what is the style of vertical scaling.
Can we take it as limited is vertical scaling, sir?
That means there is limited capacity only you can provide.
Okay.
You cannot scale up very high unlimited. Okay.
Yes.
So what exactly the vertical scaling based on the previous pick what you have seen?
We have limitation of small data we can.
Answer my question. Answer my question here.
Sir,
Number of CPUs, how many?
CPU only 2 we can do it, sir.
Number of CPUs, how
One.
many?
1 CPU.
Only one. Okay. What is the style of scaling?
Vertical.
Now that is type. In the vertical type, how you are increasing capacity, that is called style. Style of scaling is what? If RAM not sufficient, what you are doing? You are adding one more RAM chip, right?
Yes.
By adding, suppose you take processor. I cannot add one more processor, but I can replace
Replace.
old processor with a new processor by adding or
Replacing.
Replacing.
replacing components.
Component.
Components such as RAM,
RAM and processor.
hard disk.
Processor.
Got it. This is the style of scaling. But based on this, what is the problem you identified here?
We can't add more
Everything
than.
you are changing.
High capacity.
Yeah, we can't make it
High
high capacity.
Not
Possible.
because of single CPU. Got it. This is the problem. For this, the solution.
Horizontal.
Already vertical story over. The next level.
Horizontal.
Horizontal. Horizontal scaling.
Horizontal. Now how it works, we will see. That means here before a small statement I am changing over here. What is server here? For your
CPU.
application. One CPU.
1 CPU.
One CPU acts as
Server.
server. Okay. So this is vertical scaling. Let's come to the next level. Let us come to that scaling, horizontal scaling as a solution. First key, the key features I will type, later I give you picture. Horizontal scaling. This is the latest trend. Since 2006. First time who implemented this one is Teradata has implemented this. This is a database. That is first time they implemented a horizontal scaling feature. After that, the remaining things have copied that feature.
Yeah.
Observe here. Previously, who is the server?
One
CPU.
CPU.
Now a cluster acts as a
Okay.
cluster
Server. A
acts
cluster includes the server.
as a server. What is cluster? What is
Group of
cluster?
nodes.
Almost correct. A group of
Slave server workers.
network
Network.
of what? Nodes. Here nodes
Node.
means
CPU.
CPUs.
Node.
Independently, that is independently single machine is a CPU, sir. Whenever it is part of a network, that is the same CPU is called as a node. Got it? That means in our server place, not the single machine. A network of nodes, that means multiple CPUs network is acting as a single server.
It's like a cluster, you're saying.
Understand?
Yes, sir.
This is the thing. In the vertical scaling, only one mission. Here, network of
Multiple.
multiple missions.
So for
Okay.
just for understanding, sir, we can take it as cluster means multiple CPUs.
Multiple CPUs, but not independent CPUs.
Okay.
Suppose in our classroom, we are 10 people. Each person has their own CPU. But that is not a cluster. If all 10 CPUs are in a network,
Oh,
understood?
yes,
Then
yes,
we
yes.
can call it as a cluster. Understood?
Yes, sir. With one network, if we have all 10
Yes.
CPU, that is one
Yes.
cluster.
That network is serving a single purpose. Suppose data processing is your intention. The data processing will be done by entire this network.
Yes,
Understand?
yes.
That means that network of nodes is acting as a single server.
Yes, sir.
Okay, that is called cluster. Okay, what is the style? Previously, what is the style? Style of scaling.
Adding.
Oh, by adding replacing components such as RAM,
By
hard
adding
disk,
or by replacing components. But here, by adding
so style of scaling.
nodes to the cluster.
By adding
Node means CPU.
CPU.
Nodes to the same cluster.
To the same
to the
network of cluster.
Got it? So previously we discussed about problem. Now that problem is overcome.
high capacity not
High
possible.
volume of data.
What is the advantage?
Big data.
High capacity. Here capacity means in terms of storage and also in terms of processing. Okay.
So when we compare with vertical scaling and horizontal scaling, in
Hmm.
horizontal scaling, the advantage is the high capacity.
Yes.
We can do it. Okay. Vertical, we
Yes.
can't do it. It's not possible, right?
Yes. High capacity can be provided.
Provided.
Can you recommend this for the big data?
Yes.
Suppose business requirement is, per year, I'm getting 100 terabyte data for my business. What do you recommend me? Can you store 100 terabyte data into your laptop?
No, sir.
No, because that is vertical scaling. Got it. So 100 terabyte is a huge volume. That too, nowadays organizations are getting not year terabytes. Per day they are getting per terabytes of data. Suppose you take one organization, Amazon online sales. Amazon is getting per day 60 terabyte of data per day. That too, the 60 terabyte not latest news. This is very, very old news. This is the news at 2013. In 2013 only for Amazon online sales, per day they are getting 60 terabyte means, what about 2025?
It should be more than.
More than, right? Maybe 500 terabyte or 600 terabyte.
Yes.
Okay, think that per day 500 terabyte Amazon is getting. Monthly 30 days. 30 into 500? 15,000, right?
Yes.
15,000 TB means approximately 15 petabytes, right? 1024 terabyte is 1 petabyte.
Yes.
So within one single month, they are achieving multi petabytes of the data. That much of volume, so they cannot keep into single missions. Okay, they need definitely clusters.
Clusters. Yes.
Got it. So to support for the clusters, horizontal scaling is important.
Excuse me, sir. Can you give me an example in a practical way so that if we are working in a company, how do we need to use it?
Simple. Data volume less within terabyte, within less than 1 terabyte, you can go for vertical scale.
Okay.
More than 1 TB, okay, or more like just in a single day, the two organizations are getting more than terabytes of data nowadays. At that time, like you cannot go vertical scaling, we have to go with horizontal scaling.
Horizontal.
So final advantage is this one: high capacity can be provided, means high storage capacity, high processing capacity. Got it?
Yes, sir.
So this is one of the key feature. So whatever the things theoretically we discussed, if we want to give a pick for this, the pick shape is like this. Now this is network. Totally 6 nodes are here. One node I dedicate for master.
Master.
Remaining nodes, slave or
Slaves.
worker
Worker.
nodes. Let's say this is worker node 1, worker 2, worker 3.
It's known as slave or worker nodes, right?
Yes.
Master node.
Mhm. Now if I store data, where data will be stored? Okay,
Master.
before that question, think that each node capacity storage, I'm talking about only storage. First node 1 TB, second node 1 TB. Every node is having 1 TB, 1 TB, 1 TB. What is the total storage capacity?
5.
5 TB. Don't count master.
Yes.
Okay, don't count master, because finally if I load some data into this, the data is stored in slave machines.
Separately, right, sir? Data will be stored.
Yes, data loaded into
Slaves.
better loaded, better say saved into
Worker nodes.
slave. If I run a query, data processed by master or slaves?
Slave.
Still slaves.
Yes.
And data processed by?
Master.
Master.
No,
Even slave. Oh yes,
slave.
because it is individual.
Data stored in slave, processed by slave.
Slave.
Then what this bloody master is doing? Master responsible.
Sending the data to slaves.
Just to try to say responsibilities.
Responsible
Suppose
this.
you are a manager. You are a manager to my team. What are your responsibilities?
Ah.
Task.
Assigning.
Sending a
Mhm.
tasks to
And also
Monitoring.
monitoring. And also
Load. Load balance.
load balancing. And also fault
Tolerating.
tolerance.
Tolerance.
Understand the point? So here monitoring means whether work is going properly or not, that will be checked, and also health of the node also will be monitored. So if you want to assign any task to a person means first of all health should be. Similarly for the missions, it checks the health of that mission.
So sorry for disturbing. Can everyone mute your speakers? It's lot of disturbance.
So just observe this one. First responsibility task assignments, assigned task properly executed or not, master is monitoring, and also it is monitoring health of the health checkup. And load balancing also. Suppose some nodes are already engaged into the work. On that moment, if any other new task is created, okay, it has to assign the work to currently free mission, right? Or else which has less burden. To that mission, it has to assign the task. Suppose during that process, if any mission is down, immediately the running task has to be reassigned to other idle mission. So such kind of fault tolerance mechanism, everything are responsibilities of the master. This master is connected with all the slave missions. Like this, a simple shape I am providing. Let's say this is the master connected with all the slave missions. Now here total storage capacity 5 TB. Suppose after 1 year this 5 TB space got filled. What should I do? So my
Another
total cluster capacity is 5 TB here.
no more saying that
I will add few more nodes. Maybe this is worker 100. Now what is the total storage capacity based on this? 100 TB because of 100 worker nodes. Again after 2 years 100 TB also got filled. No problem. I will keep on add. This means. So how scaling is possible means what is the style? By adding. Extra nodes to the same cluster. You are not going to create a different cluster. Into the same cluster you are adding. Got it. So finally high capacity is possible. So can I keep 300 terabyte data into this? Yes. Yes. Suppose current existed cluster capacity, not a suppose current existed cluster capacity is only 200 TB, but I have 300 TB data. Not a problem. Other 100 nodes I will add and I dump this. Even tomorrow, my data reaches petabyte, not a problem. I will add other 400 nodes in this way. So this is
That's
what
why we are saying high capacity.
Can
It's
we
indirectly high capacity is possible.
Yeah, in horizontal scaling.
In horizontal scale.
For understanding purpose, sir, for horizontal, it can be also unlimited nodes can be added, sir.
That is again database to database, that is different.
Okay.
Okay, just try to come. Observe this statement. Nowadays, sir, online team, all of you observing this following? Up to now clear? Nowadays, every database is using
Horizontal scaling.
horizontal scale. That means in our practice purpose, in our training centers, our database server is a single CPU. But if you go for the real time, if you go into real time industry, their database server is not a single CPU. A cluster is acting as their server. Okay. That means cluster acts as a database server.
Sir, is there any scenario where vertical scaling has a more advantage over horizontal scaling other than less than 1 TB?
Suppose there are high-end machines. Suppose if you want to make something as a server means already in the market, 256 GB RAMs also there. Okay.
Okay, sir.
And there are some special hardwares with 10 TB hard disk storage is there. And processor already in the market, 150 gigahertz, such kind of high powered things are there. Thing that is able to deal 5 lakh users at a time. 5 lakh users at a time, that could able to deal up to 10 TB storage. Actually, my business has a requirement of only max to max 1000 users. This is my business case. That too, my data is 2 TB for the future upcoming 10 years. Think that. Now, in this case, why I need horizontal scaling? Simply vertical scaling will solve my problem or not?
Yes, sir.
In that case, you can proceed with. Generally, the organization who have less number of customers and what you call less volume of data and less number of applications also within their business, then they can proceed with vertical scaling. Instead of going for a cluster, simply one high-end machine they will purchase, they will make it as a server. Okay.
Okay, sir.
But for the biggest enterprises, let's talk about ICICI Bank. Can you imagine ICICI Bank server is a single CPU?
No.
You take like SBI, State Bank of India, or else the Reserve Bank of India. Can you imagine their server is a single CPU?
No, sir.
No.
Definitely not. Okay. So for the biggest enterprises, cluster. For small organizations, this one. Do you recommend this vertical scaling for Edify?
Yes.
For
No,
now,
no,
yes. For
no.
now, yes. Sir, max to max
Oh, vertical screen, right? Okay.
per month 300 students.
Okay.
On average, each student is performing 10 transactions. Total, how many transactions per month?
3000.
3000 transactions means the data is in not even GBs. The data is in KBs only, right? For this operation, vertical scaling is good.
It is
Understand?
basically cost effective, sir.
Cost effective. Cost effective
Okay.
means depends on capacity.
Mm.
Because here vertical scaling, I go proceed with only one CPU. Suppose 100 CPUs maintenance cost is more, or one CPU maintenance cost is more for you?
100.
100.
100 is obvious. Suppose if it is one CPU, I don't engage any hardware admin or network admin. If I am maintaining a cluster, I need additional team, right?
Yes.
So I need to maintain at least one mini data center. So monthly maintenance of cost of that data center, I need to bear it. If it is on premises, or else if it is same thing in the cloud, same thing, the monthly some cheaper cost you will pay to cloud providers, maybe Azure Cloud or GCP or AWS, whatever it may be. Understand? So let's come back to this point. Nowadays, every database is using horizontal scaling. That means like in their database server means a cluster is acting as their database server. But unlimited data storage is not possible. Data is data storage
It's not possible.
is not possible. Why? My question meaning is why? The answer for this, each database has its own limitation. For max number of nodes in the cluster. Let's check some of the few examples. Generally, industry uses two types of databases. What are those? One kind of database they are using for OLTP. Another one for
OLTP.
what is OLTP?
Online transition
Online transaction processing.
process.
Another kind of database for
No
OLAP.
SQL data warehouse.
data warehouse. What is this? Data warehouse. For example, I'm taking a list as a small table, just observe. You can understand why unlimited data storage is not possible. Most of databases traditionally RDBMS. Nowadays, every RDBMS is a cluster. But how many nodes you can keep? Max nodes. Tell me one popular database.
MS SQL.
Oracle.
Oracle.
Here 256 is the max. Suppose initially you started journey with 5 nodes in the cluster. Data volume increased, again you have added 100 nodes. Again increased, you have added another 100 nodes. In this way, up to what extent you can add number of nodes is max 256 only. Once that among these 256, again one master node, remaining 255 worker nodes. Once this 256 limit is reached, you cannot add one more node. Because of this limitation, can you say unlimited data storage is possible here?
No, sir.
No, definitely, because limits. Same kind of limit. Let's talk SQL Server, which is Microsoft database. Initially 108 nodes. After that, in the next versions, it is also 256. MySQL, in the beginning, it 54 only. After that, it also became like 108 SQL Server in the beginning. After that, nowadays with MySQL Enterprise Edition, 250. And other popular things like PostgreSQL. Here also 256. Okay. In this way, take any database which is used for the OLTP. What is OLTP? What is the purpose of OLTP?
Online transaction.
End user transaction.
Transactions. Suppose if I sign up, that is one transaction by me. Suppose in a banking application, I am withdrawing money, that is one transaction. I am depositing, one transaction. I am transferring money from one account to other account, that is one transaction. All end user transactions are captured by OLTP databases. Within this OLTP segment, the popular is RDBMS category. In the market, these are the popular databases. Still, IBM has a DB2. So here also 256 like this. Okay, suppose data warehouse is mainly used for what? For end user transactions, OLTPs. This is for
Data dumping.
historical data. Why you need historical? What is the limit here, sir? 256. For example, let's talk about SBI, State Bank of India. It has more than 70 years history. Do you mean to say entire 70 years data is available in their Oracle or DB2 server?
No.
They cannot, because very limited capacity here, 256. That's why what they do in OLTP, they maintain recent data. Remaining where entire 70, suppose example, let's say 2 years data. Remaining all?
Data warehouse.
The data will be kept into their warehouse. In this way, every organization is maintaining two types of databases. One database for OLTP,
So yes,
database for
going to be for only the recent data.
data warehouse. Main purpose, historical. Okay, so here also most popular is RDBMS. This is also a cluster. Here max nodes. Very popular database for the warehouse.
Teradata.
Teradata. After that, Netija.
Netija. Vertiga.
After that, cloud database is entered into the picture. Later we discuss about the cloud services. So here, if it is Teradata, 1024. When compared with Oracle, high capacity or not?
Yes.
Okay. So 1024. Netija 1024. I don't know why they put that limit. In Vertica 512. So that means when compared with Oracle SQL Server, MySQL 4 times bigger, right?
Yes.
That means 4 times high storage capacity. And also very high processing speed. The processing speed, that too, there is another feature. In all these things, parallel process possible. But in these things, parallel process not possible. What is the reason? Later. Now I'm going to talk about storage. Parallel process possible. What is parallel process? In the next few minutes we will come. Then you can understand what exactly that MPP in the Spark. It's all like the prerequisite information to understand the Spark we are giving. Okay, now you tell me, look at the screen, both left side and right side, OLTP databases and data warehouse databases. In which database unlimited storage is possible?
Sir, in data warehouse?
Just to check the max number of nodes and confirm me. My question, in which database unlimited data storage is possible?
Teradata and Netija.
Teradata and Netija.
Nothing, nowhere possible. In Teradata also there is a limit, right?
Yes, there is a restriction that we have to do only 256.
Maybe when compared with Oracle, 4 times extra storage you can do. But can you promise unlimited?
No.
No.
No. What is the reason?
Because of limitation, sir.
Okay, every database has
Limit.
Some limitation.
Limitation for
Data.
max number of
Nodes.
nodes.
Oh, yes.
That's why unlimited storage is not possible. Can you recommend this Teradata Netizen for Amazon?
No, sir.
For Netflix?
No.
No, sir.
No.
For Redbus?
No.
No. Because their organization per day they are getting.
Every day is increasing, sir.
They multi terabytes of data. Understand? Not per year.
Every day.
Sir, 15 years back, if you go, 1 terabyte means entire 1 year data, sir. 1 TB means entire 1 year data, some 15 years back. But nowadays, within a single day, multi terabytes. Even organizations 100 terabyte, 200 terabyte, on that way the organizations are getting the data. Okay, that's why these kind of traditional systems will not work out. So at any cost, I need unlimited storage now. So solution by.
Cloud.
So first of all, expected solution. What is the expected solution?
Unlimited.
Cloud.
Unlimited data storage. The solution is possible by next level introduction entry of the hero, that is
Hadoop. Hadoop.
Sir,
yes,
how do we pronounce that?
Hadoop, 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 Hadoop. Okay.
HDRFS.
Mm,
So this is for unlimited storage.
yes, it has two
So
layers.
you can
This has two layers. You can say these layers as services. Okay. One is storage. Second thing is process. For this storage here we have HDFS, because if you understand HDFS behavior, then only you can understand about Spark. HDFS.
HDFS.
Here process. In the beginning of the Hadoop, map reduce. After that, Tej. Now latest, Spark.
Spark.
Here we are now. Our goal is to enter into that Spark. That's why the background knowledge I am giving you. You can guess what is this?
Hadoop distributed
Hadoop.
file system.
Hadoop is what is Hadoop first of all? What is Hadoop?
Big data.
Simply say is a. Don't say it as a database. Okay, it's not a database. It's a big data framework. Within the word only the meaning is there.
Big
It's a
data
big data
framework.
framework. This framework has two services.
Storage and process.
So for the storage you have HDFS, and for the process MapReduce, outdated, Tej outdated, now latest Spark. So let's talk about the storage. Here Hadoop. So here, first of all, full form Hadoop distributed
Distribution. Distributed.
File system.
So this is the full form.
Hadoop distributed file system.
Today, just a little step in about this. Tomorrow, more discussion we do.
Okay. So do share this file, sir.
Definitely, I do. Once before closing, I will share this. Where we are. Small talk today, very brief talk on this HDFS. To understand more about this HDFS, first of all, you have to understand types of file systems. Then you can understand about HDFS, how exactly it works. What are the types of file systems?
DFS.
Simple, sir. One is NFS. Second one is DFS. You can guess.
Node files.
This is what?
Distributed.
Abbreviation you have seen.
Distribute file
Distributed
system.
Distributed file system.
Distributed file system.
NFS.
Nodes file system.
Normal, or you can say
Non-distributed.
non-distributed, or simply you can say normal. Okay. So just outlines I am giving. More deeper discussion tomorrow video about this because time is up for me. If it is normal file system, entire file data stored in single machine.
Single machine, okay.
That means CPU.
CPU.
Suppose they forget about this one. If I create some notepad file, this is my notepad file. I am saving this. File got saved. Suppose file name is of building blocks. This is the file. Where this file is stored? In my laptop.
Yes.
That means in my hard disk. Entire data is stored in one machine or multiple machines.
One machine.
One machine. This is the regular behavior of non-distributed file system or normal file system. Got it. But if it is DFS, the behavior is like this. File is divided into the DFS behavior I am writing. File is divided into
Blocks.
That is small chunks. All right. Blocks are distributed across multiple nodes of the cluster. What is cluster? In the beginning, we discussed about
Network.
it.
Networking of nodes.
Network of nodes. That means you have multiple CPUs, right?
Yes.
File is divided into small chunks. These chunks are called blocks here. These blocks are distributed across
Nodes.
Multiple nodes of course.
This is the thing. Let me come back. Sorry. Now step into the HDFS. What is the type of file system? Normal or DFS?
DFS.
Yes.
This is DFS. What is the behavior? block distributions. Across
Multiple
Nodes. Multiple
multi-
nodes.
multi-nodes of the cluster. Already complete statement in the previous screen I have read. Treat this as a cluster. You have 5-node cluster for simple example. In HDFS, in the beginning block size, 64 MB. After that, they modified this as 128 MB. Nowadays, latest 256 MB.
MB.
Latest version. This is latest. Okay. Suppose you have a file employee.txt. All your employees data is available here. Think that the size is 1 GB. 1 GB means how many MBs?
4 blocks.
1024 MB. What is the blocks? How many blocks are here?
4.
4 blocks.
1024 MB divided by block size.
256 MB.
That means 4 blocks. Okay. As block 1, block 2, block 3, and block 4. Okay. Block 1 stored in worker 1. Block 2 stored in other node. Maybe worker 2 or maybe worker 3, whatever it may be. Master will decide it. Which block has to be stored in which worker. The master is deciding. Let's, for easy understanding, make them a sequence. Block 3 in worker 3. Block 4 in worker 4. In the case of normal file system, where this entire 1024 MB, in case of normal file system. Hello.
Only in one file.
Within one system.
Only one mission. But now, in the case of HDFS, the type is a DFS. Behavior is file is divided into blocks. Blocks are distributed across multiple nodes of the same cluster. Okay. In this style, is there any problem if my file size is 1.5 TB? Actually, think that you have a laptop. Storage capacity is 1 TB. But your file size is 1.5 TB. Can I store 1.5 TB file into your 1 TB?
Mm-hmm.
No.
No.
In case of Hadoop, can I store?
Yes.
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 Understand. Suppose space not available. Space not available in my Hadoop also. Not an issue.
It will be done, sir, because of block distribution.
I will be adding a few more nodes, right?
Yes.
Yes.
Okay. Horizontal scaling feature is there. Got it. Suppose 5 TB, the 5 nodes space is not enough for me. I need 8 nodes. Other 3 missions I will add to the same cluster.
Yes, sir.
Then I can dump big files into this one.
Yes.
So this is the HDFS behavior. Because of this HDFS, 2 benefits I am getting. 1 minute. So here primarily 2 benefits. Of course, still other benefits are there. Mainly I am talking. Number 1, unlimited data storage. Let's talk about Oracle. Node 1, Node 2, Node 3. How many?
256.
256. Can you promise unlimited? No. But in Hadoop, it can be 512.
Yes.
It can be 5,000 also.
Because multiple nodes.
There is no limits. How it is possible means?
Do.
No limits. For
Hadoop.
max number of nodes in the cluster. So when there is no limit, indirectly you can say unlimited data storage. The second benefit,
Parallel process.
because of DFS, that means block distribution. Parallel process is possible. Parallel process is possible. How? How?
Because of multiple nodes they are there.
Okay, small story. You are a person. Your capacity. You can break a stick at a time in 1 minute. Okay. Now the task is, I am submitting you 10 sticks to you. In how much time you require? Your capacity is at a time, 1 stick you can break in 1 minute.
10 minutes.
If I submit 10 sticks, you need definitely 10 minutes time, right? Okay, instead of doing that, let's form as a team members. Okay, think that we are a network of team. We are 10 team members. I have assigned a task 1, that means stick 1 to person 1, stick 2 person 2, stick 3 person 3, like this, stick 10 person 10. For each person, 1 stick I have distributed. Now all people, not one after one, all people started breaking the stick at a time, one time. Now what is the time to process
One.
the sticks? 10 sticks, 1 minute. Suppose 100 team members, 100 sticks are there. What is the time?
1 minute.
1 minute. Understand? That is the power of parallel process. Okay, now come back to the previous peak. Think that your data has been stored in 5 machines or 4 machines. Previously, think that in a single node machine, to process your data, 10 minutes is the time. To process your data, 10 minutes is the time. Now what is the time? If my data is in 4 machines, what is the time to process that data?
2.5 minutes.
10 minutes divided by 4.
4.
Because 4 machines are parallelly processing, right? So 10 minutes divided by 4. What is the time now?
2.5.
2.5.
It is time reduced means speed increased, right?
Yes, sir.
Okay. So that is the second advantage. So finally, what you are achieving with this parallel process?
Speed.
What you are achieving with parallel process? High.
I
High. Think that one biggest process by Oracle database, 10 hours. For the biggest volume of data, one biggest process by the Oracle database, 10 hours. One biggest process. by Oracle DB in 10 hours. In Oracle, there is no parallel process. This is non-parallel
Parallel process.
in 10 hours. Now Hadoop cluster has 100 nodes. That way as a workers. Think that file data is biggest file, that's why distributed into 100 machines. I mean nodes. Now what will be estimated processing time? Tell me. Previously 10 hours. Now same data distributed into 100 machines. Now estimated time is what? 10 hours divided by 100 machines. What is the result? 0.1
1.
0.1 hour. 0.1 hour means how many minutes?
6 minutes.
6 minutes. Because 1 hour is having 60. 60 by 10. 6.
Divided.
Same data volume, but by the Oracle 10 hours, by the Hadoop, that is 6 minutes. So this is just the speed is just because of parallel process. Again, because this parallel process is because of what?
Hadoop. DFS.
Distributed file system. Again, this DFS is because of I want to implement DF means what is the eligibility? What is the eligibility? Cluster. Because of cluster, what is possible?
Horizontal.
Horizontal scaling.
In this way. Because of horizontal scaling facility, cluster is done. Because of cluster only, DFS is possible. Because of DFS, parallel process is possible. Because data is now, your file data is not stored in single machine. Data is distributed across multiple machines. Understood? Okay, more technicals in tomorrow's session we will discuss. Just wait, hold on the line. I share this. The title Spark. What is the batch code? 2504. 2504.
2504.
So entire Spark course, I will keep in this document only. Suppose this is day 1. Instead of going with Spark, what is the major agenda? Let's say big data intro, okay? That's all the things about big data intro. So tomorrow's session I will add as a separate tab. Entire our Spark will be into this single documentation. Just go through with this. Wait, sir. I'm going to share.